Hello friends, welcome to Osongato. This is Prosonno. In our previous class we are discussing about vectors. Today in this class we'll be seeing how we can add to vector using parallelogram law of vector. So let's continue. Okay. So in your previous class we have seen how triangular law can be used to add to vector. In this we have seen this is the way we solve the problem. So we get that r is equal to root over p square plus q square plus 2pq cos alpha, where alpha is the angle between the two vector, and the direction of the resultant vector will be tan theta, where theta is the angle made by the resultant with vector p. It is q sin alpha by pq cos p plus q cos alpha. Okay. Now let's comes to the parallelogram law. What will happen? As you can see, we are using these two vector. We are, let's say, we are using this vector and this vector. If we move this vector here and this vector is here, we see that we get two vector p and q. They are part of a parallelogram. Now if we draw a parallel of OA or vector P along the point B, then we get this line, and draw another parallel of OB from point A, we get AC. So the diagonal diagonal OC will represent the resultant vector for these two vector. What is the statement? Parallelogram law of vector addition. If two vector can be represented by the two adjacent sides of a parallelogram drawn from a point, then their resultant sum vector is represented completely by diagonal of the parallelogram drawn from the same point. So according to this, P plus Q, this is the two vector will be equal to the R. Now if you see it clearly that it's a part of the same law, we can prove this by using the same method as we prove the triangular law. In triangular law, we drawn a perpendicular from C to the elongated part of the OA, and that C, the perpendicular drawn from C will cross the line OA at D. Okay, so let us consider let us consider two vector P and Q are represented by two sides two adjacent sides of a parallelogram OA CB. Okay, so OA is equal to P vector and OB is equal to Q vector. Let's now we are now we draw a perpendicular from C on the extended part of OA. So we get OD, sorry, CD perpendicular OD, and OD from equal to OA plus AD. Okay. If now angle between the two vector and angle between them is alpha, angle BOA is equal to alpha. Okay, angle BOA is equal to alpha. So if this is alpha, this also will be alpha. Now what will happen? So as we can see that OA represented by OB represented by Q, and diagonal OC is equal to R. So according to parallelogram law, P plus Q is equal to R. We have to find out so what will be the value of R? So let us find it out. After that we can write it here. Now from triangle COD we get what we get? We get that angle CDO equal to 90 degree. So OC square is equal to OD square plus CD square. Okay. Now OD means OA plus OA plus AD whole square plus CD square. Okay. Let's find out what will, let's say this is 1. Next, same things. So what will happen? No, this is alpha, this is alpha, this is theta. From triangle ACD we get what we get? From triangle ACD we get that angle ADC is equal to 90 degree. So AC square is equal to AD square plus CD square. Okay, let's say it is 2. So from 1 we get what we get? OC square is equal to OA plus AD whole square plus CD square equal to OA square plus AD square plus 2 OA AD plus CD square. Okay, now OA square plus 2 OA AD plus CD square plus AD square is equal to OA square plus 2 OA AD plus AC square as from 2 get CD square plus AD square, CD square plus AD square equal to AC square. Okay, now what is the value of OA? OA means P, right? So OA is equal to P, OA is equal to OA into mod P is equal to P. So OA means P square plus 2P. AD means, now as you see, AD means AD, right? So AD means, if we say that this is AD, so AD will be let's say sine cos alpha. Cos alpha means AD by AC, okay, or AD is equal to from triangle ACD, AD equal to AC cos alpha. And what is the value of AC? Value of AC is Q cos alpha. We can write Q cos alpha plus AC means Q square. So we get P square plus Q square plus 2PQ cos alpha, and OC means R square. Okay, this is the proof of parallelogram law. So from this we can get the value of R. Also same way as we get the direction tan theta, same way we can get the value of tan theta as of triangular law of vector addition. We can get this way, CD by AD. Okay, what we get? We get here CD by OD is equal to Q sine alpha by P plus Q cos alpha. This will happen. This will be the direction. So this is the parallelogram law. It's very simple, very easy, and it's also same proof for triangular law and parallelogram law. That is a very important assumption from this parallelogram law. What is the assumption? Let us say we are getting two vector. We are getting one vector from P and Q, right? We get the R vector. Now let us say we have only R vector. As P is equal to, let's say, as P vector plus Q vector is equal to R, we can also write R vector equal to P plus Q, right? As we can see that in vector algebra, R is equal to P plus Q. Okay, so that means we can break vector R. We can break vector R into two parts. One is P, one is Q. One is along the direction OA, another is along the direction OB, right? So any vector can be divided into two vectors. Now when these two component, these are called the component of vector, when these divided two part is perpendicular to each other, what they called? Now let's, if this component, let's f is the vector, we are dividing these along the x-axis, along the y-axis, then they are called component of the vector. That is, vector f is equal to fx plus vector fy is equal to vector f. And what is the direction of fx? Direction of fx is fx I cap plus fy j cap is equal to f. As from parallelogram law we see that we can get one vector from two vector. In the opposite way we can say that we get two vector from one vector. And what is the significance of this vector component? In later part of our journey we will see that it is very helpful for vector algebra or vector calculation of various types of vector. It is very simple because this component has no influence in this direction and this fx component has no influence in the perpendicular direction of it. As a result, it is independent of fx and fx is also independent of fy. Okay, but f is totally dependent on fx and fy. Okay, it may be confusing, but in later after we use the vector component vector, then it will be very, very clear to you. So for the moment, just remember we can break a vector into two components. One is along the x-axis, another is along the y-axis. And what will be the value of fx? What is the value of fx? The value of fx will be f cos theta. Okay, if this is theta, it will be f cos theta, and fy is equal to f sin theta. How do we get that? As you can see, this is the hypotenuse of the triangle OABC. From triangle OAC we get what we get that sin theta equal to sin theta, not sin theta, let's say we get that cos theta equal to OA by OC, or implies that OA is equal to OC cos theta. And what is the value of OC? OC is f cos theta. And what is the value of OA? OA is fx. Fx is equal to f cos theta. In the similar way, sin theta is equal to CA by OC, and CA is equal to OB. Sin theta is equal to CA by OC, and we can write it down OB by OC. And what is the value of OB? OB is equal to OC sin theta is equal to f sin theta. So f y is equal to f sin theta. Okay, so x component of any vector will be cos theta component, and the y component of any vector will be sin theta component if we take the angle with respect to the x-axis, Okay, clear? So today we'll finish it here. We'll be discussing about vector multiplication in our next class. Okay, take care. Goodbye.